So this section is going to be on multiplying and dividing rational expressions. And so just a couple of steps that we're going to go through first, and then we'll look at some examples. So the first thing, and this is very, very important that you do that, is that you always fully factor both the numerator and the denominator before you do anything else. If you start by just multiplying the numerators and multiplying the denominators together, you're going to get a very, very large, complicated polynomial function that is just going to be impossible to simplify. So make sure that you're fully factoring and canceling out before you do anything else. If you forget to do this, it's going to become unsolvable and you're going to spend a lot of time doing it. So make sure that you remember that and things will go much easier. The next thing is your non-permissive values. The non-permissive values must be included in the final answer. So make sure that you're always finding those before you start canceling things out, and make sure your final answer has those in it. When we have a division, we're going to change it to a multiplication. And so the rule for that one is if you multiply by the reciprocal of the divisor, that's going to be an equivalent operation then to division. So if you see the division sign, we're just going to take the divisor, which will be the second rational expression listed. We're going to flip the numerator and denominator, that's the reciprocal, and then it's just going to be a multiplication question. Now one extra thing with division, and we'll look at this when we do a couple of examples. For the divisor then, both the numerator and the denominator are going to be a place for non-permissive values, and so we will have one extra term to look for non-permissive values when we do division there. It doesn't apply to multiplication, but it will for division there. And the last thing then, we're going to simplify the same thing as we did before. Any factor that appears in both the numerator and the denominator, we're going to cancel those ones out. And it doesn't matter if they're in the same fraction or not. So when you're doing the multiplication, you can basically cancel out factors between different fractions. All right, so let's do a couple of examples here. And so for our first one then, we'll start by factoring, as we always should. And so if you look at our first factor or fraction here, we can take an x out of that term in the numerator. So I'll factor out an x, and that'll leave me then with x minus 6. And then if I look at the denominator, I can factor out an x again, and that'll leave me then with x plus 5. When we look at our second factor, we have then the x squared plus 7x plus 10. We're looking for numbers that multiply to 10 and add to 7. So 5 and 2 will give us those. So that gives us x plus 2 and x plus 5. And then in the denominator here, we have then, we can take out our greatest common factor then of 3. Now, if we look at this, if we take out a 3, that'll give us a minus x here, and then a plus 6. So we're trying to match it up to this one over here. So if you recognize that right away, we can take out a negative 3 right away, and that'll leave us then with negative 6 plus x. And we'll see then that is actually going to cancel out. If you just pull the greatest common factor of 3, you'll get 6 minus x. You'll see that the signs are just different, and then you can pull out that negative one after. But if you recognize it early on, you can save yourself a step. We'll went into our non-permissive values of this one at this point as well. And remember, we're just looking at denominators for that. And so each term can't equal 0. So x can't equal 0, x plus 5 can't equal 0, which leads us to x can't equal negative 5. And negative 6 plus x can't equal 0, which leaves us then with x can't equal 6. And so if we put those in just at the end, we have x cannot equal the negative 5, the 0, and the positive 6. And again, if we put them in numerical order, it's a little bit easier just to keep track of, but you don't necessarily need to do that. Then we can go through our different factors there and cancel anything out that shows up in the numerator and denominator. And remember, it doesn't have to be in the same fraction. We can cancel things out between fractions. The first one to look at is this x over x. Those two cancel out. We have our x minus 6, and this, if you just change the order, will be x minus 6 as well. Our x plus 5s then cancel out. Again, you can go between fractions. And then what we're left with then is x plus 2 over negative 3. Again, normally we'll take that negative out front, x plus 2, and then all over top of 3. And you could also multiply the negative 3 there and get negative x minus 2. That would also be fine. X can't equal negative 5, 0, and 6. And then that will be your equation in simplest form for that particular factor. So I'm going to recommend that you just take a moment to pause the video, give the next one a try, and then restart the video and see how you did. So this one has 4 quadratic equations that we'll need to factor, and there will be just a lot of factoring as you're going through these sorts of questions. So our first one, x squared minus 3x plus 2, we'll factor to x minus 1, x minus 2. If you look at x squared plus 3x minus 4, that'll go to x plus 4 and x minus 1. And then we'll multiply that then by the x squared plus 9x plus 20. We'll go to x plus 5, x plus 4. And the last one, the denominator there, we'll factor then to x plus 3, x minus 2. If we look at our denominators for our non-permissive values, x plus 4 can't be equal to 0, so that gives us a negative 4, a plus 1, a negative 3, and a plus 2. So once we have our non-permissive values, then we can look for things that will cancel out. And so I have an x plus 4 and an x plus 4, x minus 1 and x minus 1, x minus 2 and x minus 2. And I'm left then with just the x plus 5 over x plus 3. And then don't forget, of course, your non-permissive values. And I'll just put these in numerical order. So negative 4, negative 3, 1, and 2. And so that'll be your final answer then for that one. All right, so next we'll look at some division questions here. Now with our division questions, remember, we're going to start by taking the divisor. We're going to take the reciprocal of the divisor and change it into a multiplication question. So the second term listed here will be the divisor. And so what we'll do is we'll take then the 4x squared minus 12x. And so we'll just leave that alone for the moment. And we'll put that then over x squared minus 9. Now this is the one that we're going to flip. And so that's our divisor. And so what we're going to do is we're going to take this denominator, put it in the numerator, this numerator, put it in the denominator, and that then changes this operation to a multiplication, and then we can do it the same as we've done before. So then we'll get x squared plus 4x plus 3, that'll be in our numerator. We'll get 7x cubed plus 7x squared then in our denominator. Now it's just a multiplication question as we've done before, and so we'll start by factoring. I can factor a 4x out of my numerator here. That's just going to leave me then with x minus 3. Then I have a difference of squares in the denominator, and so that'll be then x plus 3, x minus 3. And multiply that. This one here I can factor. I need a product of 3 and a sum of 4, so that'll be 3 and 1. So x plus 3, x plus 1. And in my denominator here, I can take out a greatest common factor of 7x squared. And so I'll have 7x squared, and that'll just leave me then with x plus 1 in the denominator. Now I'm going to look at all of my denominators here first for non-permissive values. So x plus 3 can't equal 0, x minus 3 can't equal 0, so that'll leave me then with a plus or minus 3 that x is not allowed to be equal to. And you can just group those together like that. If x squared can't equal 0, then x can't equal 0. And if x plus 1 can't equal 0, then x can't equal negative 1. Now the other thing you have to do with your divisions is just recognize that this x squared plus 4x plus 3 was still in the denominator of my original function. Now I've moved that to the numerator here, but at one point it was in the denominator, so these ones too cannot equal 0. Now what you'll often find is that these ones just repeat, and so x plus 3 can't equal 0, that's the negative 3 we already have. X plus 1 equals 0, or can't equal 0, that's the negative 1 we already have. But you always need to check for that because sometimes you could get extra non-permissive values then from the numerator. And so the denominator of this first term, but for division, it's both the numerator and denominator of the divisor there that you have to be looking at. So we can cancel things out. This 4x will cancel out with one of those there. So I'll take that x squared down to an x. X plus 3, x plus 3. The x minus 3s cancel out. The x plus 1s cancel out. And so in this case here, what we'll be left with then is just 4 over 7x. Where x cannot equal plus or minus 3, 0, and 1. So what I'm going to recommend that you do is just pause the video, give the next one a try, and then restart it and see how you did. So this next one is going to be a little bit more involved in terms of the factoring because we have coefficients in front of the a value there. So I do just want to actually spend a little bit of time going through those factoring the 6x squared expression, the two denominators there. And then we'll go back to factoring those ones there. So if we just start with the 6x squared plus 11x plus 3. Now to factor these ones, remember we take the a value here, which is 6, times the c value, which is 3, so that's giving us 18. So we need a product of 18 and, a product of 18 and then a sum of this middle term 11. And so 9 and 2 will give us that. So we'll break that middle term up into 9 and 2. So we have 6x squared plus 9x plus 2x plus 3. You can put those in either order. And then we can do our factoring by grouping. We'll take a 3x out of those first two terms. So we'll take out the 3x, and that'll leave us then with 2x plus 3. And then the next term, we already have that 2x plus 3. So essentially we're just taking out a plus 1. That'll leave us then with that 2x plus 3. And then I can take my two groups. I can factor out the 2x plus 3. That leaves me then with 3x plus 1, and then times the 2x plus 3. And that'll be the factored form then of this top expression over here. We can use the same pattern then to do the 2x squared minus 7x minus 15, and the 2x squared minus 9x minus 5. And so again, for this one, you're looking for 2 times negative 15, so you're looking for a product of negative 30, a sum of negative 7. And so for that one, we can use negative 10 and 3. And then for this one, 2x squared minus 9x minus 5, we're looking for a product of negative 10, so 2 times negative 5, a sum of negative 9. And for that one, we can break that one up into negative 10 and plus 1. So I won't go through all the factoring for all of those ones, but it'll follow the same pattern as we used for this one here. I will just jump straight then to the factored form of those ones then. We'll write that one out, and then we can look at the division then, of course. And so for this one, I'll get then 3x plus 1 times then the 2x plus 3. And that's just coming from the factoring that we did up here. Over here then, if I do that denominator, I'll do 2x plus 3 and x minus 5. The 9x squared minus 1 is going to be then a difference of squares. And so then we'll get 3x minus 1 and 3x plus 1. And that'll be all over top of then this one here. If we do again sum product and factoring by grouping, we'll get a 2x plus 1. That's right, I'm 15. And then another x minus 5. So this is a division sign here. So I'm going to take the reciprocal of this, and that will change that to a multiplication. So we get 3x plus 1. So the first one's going to be the same as it was before. Now this one's going to change to multiplication, and I can do that by taking the reciprocal of that divisor. So 2x plus 1, x minus 5 in the numerator, and that'll all be over top of then the 3x minus 1 and the 3x plus 1. Now I'm going to look through, again, all of my denominators for my non-permissive values, and again, we also have to look at the numerator then here of my my divisor. So this first one here, we'll actually just run through this equation here. So the 2x plus 3, so if I have 2x plus 3 can't equal 0, move the 3 over, that'll give me 2x, can't equal negative 3, divide both sides by 2, and I'll have 2x, or x cannot equal negative 3 halves. And so with your fractions, again, you'll just have the one extra step. You'll still set the divisor or the factor equal to 0, and then just solve for x. You'll move the one term over, and then you'll have a division. So if we look at our non-permissive values then for this one here, I'll have x can't equal negative 3 halves. That one there. This will just be then positive 5. This one here will be then positive 1/3, and this will be negative 1/3. And so I'll get that plus and minus 1/3. Now I do have to again look at this numerator up here as well. So just make sure you're looking at both of those terms. Now the x minus 5, that leads to the 5. We already have that. But the 2x plus 1, that'll lead us then to a negative 1/2 as another non-permissive value. So again, just make sure you're always looking for the numerator of the divisor. And that's just because when it was over here, it was still in the denominator. It's over here as well. And so you have to then still include that. So here then, if we then cancel out then our terms, we have a 3x plus 1, a 3x plus 1, x minus 5, x minus 5, and then the 2x plus 3 will cancel with the 2x plus 3. I'm left with 2x plus 1 over the 3x minus 1. And then with my list of non-permissive values. And again, watch, there is a lot of factoring in some of these ones here. And so the faster you are at factoring, the quicker you'll be at these questions then as well. Now the next couple then will be what are called complex fractions. Now a complex fraction, we're not going to solve these any differently than we've done before, but the initial form looks a bit different. So just remember that when you have this fraction divided by another fraction, this middle line here just means division. And so I can rewrite this just as a standard division question. And so what we'll end up with then is just x squared minus 8x plus 15, all divided then by the x squared minus x minus 6. And then I'll divide that by the x squared plus x minus 20, and then all over top of x squared minus 6x plus 8. Now we are going to take the reciprocal and multiply by the reciprocal, so you certainly could do that right away when you're doing that step, but let's put in that extra step there. So maybe we'll start by factoring these ones right away. And so when I factor that first one, I need a product of 15 and a sum of negative 8, so negative 5 and negative 3. So we'll take then x minus 5 and then x minus 3. When I factor this denominator, I'll take negative 3 and plus 2. I'm looking for a product of negative 6 and a sum of negative 1. Now I'm going to change this right away to a multiplication. And so I'm going to take this divisor here, and this one's going to go, of course, to the numerator. And so when I factor then that x squared minus 6x plus 8, I need a product of 8 and a sum of 6. So negative 4 and negative 2 will give me that. So I'll have x minus 4 and then x minus 2. And then this numerator, I'm going to drop right down to the denominator. Again, I'm taking that reciprocal so I can change this into a multiplication. And I'll just do that in one step for this particular question. And so it'll give me then x plus 5, x minus 4. And because we're looking for a product of negative 20, so 5 and negative 4, and a sum of 1, so plus 5 and negative 4. So then we can look at our non-permissive values then at this point over here. And so I need to look at all of my denominators, but then also this numerator, because remember back here it was a denominator. So plus 3 from this term, negative 2, negative 5, plus 4, and then I have that plus 4 and then a plus 2 here. And so again, very often you'll get a repeated one here, but you get one extra one showing up there as well. So always make sure you're checking there. So in this case, x cannot equal positive 3 plus and minus 2, negative 5, and positive 4. And so just make sure you're getting all of those ones in. And then we can cancel things out that repeat. And watch your signs carefully. Things might look similar, but if the sign's wrong, then of course you can't. So the x minus 3's, those can both be taken out, and the x minus 4's. So x plus 2, x minus 2, those are different. X minus 5, x plus 5, those are different, and so those ones will all stay in. And so then I'll be left with then x minus 5, x minus 2 in the numerator. And that'll all be divided then by x plus 2 and x plus 5 then in the denominator. Now, there's no need to multiply these ones out. You certainly could, but I'd recommend just leaving it in that factored form. Okay, so I recommend then that you just pause the video for a moment, give this next one a try, and then restart the video and see how you did. We have this line kind of right through the middle, and that line, of course, just means a division there. And so I'm going to take this top fraction and I'm going to divide it by the bottom fraction. Now remember, I can change that division to a multiplication, so I'll do that actually right away in the first step for this one here. So certainly you can do it in more steps, but just to save a little bit of writing here. So 10x squared minus x minus 3, all over top of then 2x squared minus 5x minus 3. Now I'm going to change this to a multiplication, so that means I'm going to take the reciprocal of this, and so then that 2x squared minus 18 is in the numerator, and then the 5x minus 3 will be in my denominator. And so you can do that in one step. You can also just write it out with the division. You'll have those two flipped around, and then you can change it to a multiplication then in the second step. This one here, we'll have to do a sum product and a factoring by grouping. So I get 10 times negative 3, so I'm looking for a product of negative 30 and a sum of negative 1. So I can break that that term up into 5, or positive 5 and negative 6, and then do my factoring by grouping. So if I do that, then I'll end up with then 2x plus 1 and 5x minus 3. We can do the same thing with the bottom term. Look at sum product, and again, the factoring by grouping. And I'll get 2x plus 1 and x minus 3. This one here, I can do a greatest common factor of 2. And then what that'll leave me with then is, when they take out of 2 is x minus 9, which is then a difference of squares. And so I'll just jump straight then to the factored form of that. So you'll end up with 2x minus 3x plus 3. And then there's nothing I can do with this one here in terms of factoring. And so I'll be left with then 5x minus 3. And we'll go through all of our non-permissive values. And we'll get fractions here. So here I'll have x can't equal. This one will give me negative a half. This one here will give me a positive 3. I have a minus 3 up here as well. And so I can put in then the plus and minus 3. This will give me 3/5. Again, just set that whole factor equal to 0. And so then I have all the ones I'm looking for. Again, so I get some repeats up here. But again, just make sure you're getting all of those. Then we can go to our canceling out. I have a 2x plus 1, a 2x plus 1, 5x minus 3, 5x minus 3, and then my x minus 3's cancel out as well. And I'm left with 2 times x plus 3. Now you can multiply that out, or you can leave it as basically 2 factors, however you want to leave that. So 2 times x plus 3, or you could go 2x plus 6, and that would certainly then be fine as well. Now you can do word problems with these ones as well. So they're not going to change a lot. We'll still kind of work through them the way we normally do a word problem. We'll just end up having to multiply some rational expressions together for these particular types here. And so for this first one here, we're just looking for the area of this rectangle. So we have 2 questions here. One is to determine the area, and then we'll solve for an exact value given an x value there. But we'll start with just finding the area. And as always, your area is just length times width. And so that's all we need to do with this one here. So I'll take one side of the x squared minus 4x plus 4. Divide that then by 5x. And I'm just multiplying that then by 20x all over top of x cubed minus 2x squared. And now we're in a form similar to what we've been doing kind of up to this point. So for this one here, this can be we can factor this one out to a negative 2 and a negative 2, so it'll be a perfect square trinomial. So x minus 2, x minus 2, and that'll all be over top of 5x, which of course you can't factor. And again, multiply that by 20x, also can't factor. Now this bottom one, though, I can take an x squared out of, so I'll factor out the x squared, and I'll be left then with x minus 2. Now we do still want to pay attention to non-permissive values, because if our final answer works out to be one of those, then of course it'll be a non-solution. So x can't equal in this case the 0 and the positive 2. So then we can go to our canceling from here. So I'll take out an x minus 2 and the x minus 2. Now these x's here are going to cancel out as well. Now the other thing I can do is I have 20 over 5, and so that's just going to equal 4. So do also take your constant terms and make sure you're dividing those ones out as well. So I'll be left with a 4 in the numerator, an x minus 2, and then this x squared will also be then in the numerator. And I'm looking for the case where x can't equal 0 and 2, so those will give me non-solutions. But this will be then the area function then for that particular rectangle. Now for the second part, I'm just going to put this in and I'm going to just solve for that value. Now this will be then just some simplifying with radicals, but just a matter of subbing that area or that value then into our area equation. So we'll have 4, I'll put in then 4 root 5 minus 2, just a straight substitution there. And then I'll take that 4 root 5 in for x, and then we'll square that value. In my numerator, I'll multiply that one through, and so then I'll get 16 root 5, and then minus 8. And then in the denominator, now don't forget you have to square the 4, so that'll give us 16, and then the root 5 squared will give us 5, and so I have 16 times 5, which is going to give me then 80. Now you won't want to leave it like this, because the 16, the 8, and the 80 are all divisible by 8. And so 16 divided by 8 is going to give me 2. The root 5 stays as it is. 8 divided by 8 is just going to be the 1. And then 80 divided by 8, of course, is 10. So 2 root 5 minus 1 over 10 will give me then the area of the rectangle. Now, I don't have any particular units for this one. If you were given units, you would include them. But whatever units these happen to be in, 2 root 5 minus 1 over 10 will be your solution for that.